There are moments when the human body is pushed to its absolute limit, when the very fabric of consciousness begins to fray. It's the third consecutive night of a newborn's feverish cries, the final caffeine-fueled push before a career-defining deadline, the disorienting haze of international jet lag. In these moments, we become intimately familiar with the ghost of sleep deprivation. The world takes on a dreamlike, muffled quality. Thoughts become sluggish, emotions raw, and the simple act of existing feels like walking through deep water. And then, when the ordeal is finally over, comes the crash. It is not sleep as we know it. It is a surrender, a total, unconditional capitulation to a biological force so powerful, it feels like a physical law. We have a simple, almost transactional name for this phenomena. We are paying off a sleep debt. It's a tidy metaphor that captures the feeling of owing something to our bodies and finally making good on the payment. For decades, however, this explanation has been a placeholder, a scientific I owe you. The feeling was universal, but the mechanism was a mystery. What precisely is happening in the brain during this profound state of recovery? A landmark study published in the journal Science in mid-2025 titled "Where the Brain Pays Sleep Debt" has finally pulled back the curtain. This research doesn't just give us a clue, it provides a precise address. For the first time, scientists can point to a map of the brain and say, here, this is the place. This is the engine room of deep restorative sleep. They have identified a specific elite cluster of neurons in the thalamus as the master conductors of the brain's most powerful recovery state. The grand central station of consciousness. To understand just how revolutionary this finding is, we must first appreciate the role of its location, the thalamus. Buried deep within the brain, far from the wrinkled cortex we associate with higher thought, the thalamus is the undisputed gatekeeper of our reality. It is the grand central station of all our senses. Every sight, every sound, every touch that streams into our body must first pass through the thalamus before it is granted a ticket to our conscious awareness. It is a triage nurse, a traffic controller, and a bouncer all rolled into one, constantly filtering the world to prevent our minds from being overwhelmed. During sleep, this role becomes paramount. The thalamus initiates a master lockdown protocol, closing the gates to most sensory information. This is what allows you to sleep through the hum of the refrigerator or the gentle rustle of leaves outside your window. For a long time, this was considered a largely passive role. The thalamus simply put up a do not disturb sign so the rest of the brain could rest. But this new research reveals that a small, specialized neighborhood within this bustling station is anything but passive. It is home to a black ops team of neurons, waiting for the call to execute the brain's most critical mission. The science study illuminates that when we are sleep deprived, our brain doesn't just passively shut down. It activates a highly specific and powerful recovery protocol orchestrated by this elite group of thalamic neurons. They are the brain's SEAL Team 6, its emergency response unit. Their job is not just to induce sleep, but to induce the most potent, efficient, and restorative form of deep sleep possible. When the researchers observed the brains of lag models who were sleep deprived, they saw this thalamic circuit explode with activity during the subsequent recovery sleep. This wasn't a tired system collapsing. This was a specialized system being deliberately and forcefully engaged. This is the biological reality behind paying the sleep debt. That profound gravitational pull into a sleep so deep it feels like you've left the planet is the sensory signature of this neural commando unit taking control of your brain. It is an active, targeted, and powerful biological countermeasure, not a passive consequence of exhaustion. Imagine your brain's normal nightly function is like a city's standard police force, patrolling the streets, keeping order, and handling routine maintenance. Now imagine a citywide crisis, a blackout of sleep deprivation. The city doesn't just fall into chaos. Instead, a call goes out and an elite, specialized task force is deployed. They are more powerful, more efficient, and have one mission: restore critical functions and stabilize the city as quickly as possible. This is what these thalamic neurons do for your brain. They are the specialists called in when the standard systems are overwhelmed, and their intense, focused activity is what makes recovery sleep feel so profoundly different from our ordinary slumber. A discovery that will reshape our future. Pinpointing the exact location where the brain pays its sleep debt is more than just a fascinating piece of trivia. It's a discovery that will reshape the future of medicine and our relationship with sleep itself. First, it decodes the very feeling of refreshment. That priceless, often elusive sensation of waking up feeling truly restored, clear-headed, and ready for the world is not a mystery anymore. It is the signature of this elite crew having successfully completed their mission. This creates a tangible biological target for measuring sleep quality. We can now imagine a future where we can assess not just how long a person slept, but how effectively their thalamic restorative circuit was engaged. Second, it throws open the doors to a new generation of therapeutic interventions. Current sleep aids are notoriously blunt instruments. They're the pharmacological equivalent of a sledgehammer, inducing sedation that often lacks the intricate restorative architecture of natural sleep. This discovery provides a target for a scalpel. Imagine a pill for a jet-lagged diplomat, an exhausted ER doctor, or a soldier in the field that doesn't just induce stupor, but specifically and safely activates this restorative circuit. It could be a therapy that helps the brain pay its sleep debt with incredible efficiency, delivering the benefits of a full night's of recovery in a fraction of the time. And finally, this research snaps into place a crucial piece of the larger puzzle of brain health. When we consider it alongside the research on sleep fragmentation and Alzheimer's, the grand picture becomes clearer. If a broken night allows toxic proteins to spread through the brain like insurgents breaching a city's walls, then this powerful, deep sleep driven by the thalamus is the elite counter-assault team the brain sends in to hunt them down, repair the damage, and restore order. It is our built-in biological defense force. This discovery is a profound reminder of the silent, elegant intelligence humming away within us at all times. The universal human experience of collapsing into a deep, restorative sleep after a period of intense exhaustion is not a sign of failure or weakness. It is a demonstration of one of the most sophisticated and powerful survival mechanisms we possess. We now know that deep within the command center of our brain, a team of specialists is always on call, ready to be deployed to defend, repair, and restore the very essence of who we are. The brain does not just indebt itself. It has its own expert financiers, its own crisis managers, ensuring that the debt is always, ultimately, paid.